Our third and final transformation that we're going to learn about in this unit is called a rotation. We also call it a turn. All right, the important thing we need to know about a rotation is that it is also considered a rigid motion, and it is also a direct isometry. The really important thing that we need to know about a rotation is it is always counterclockwise unless it's specified otherwise. All right, and we'll talk about what that means when we start to talk about the notation and the different types of formulas and degree measures that we have. The rotation is going to have three different formulas that you're going to have to memorize, and they are a little bit different than the other ones that we've done. So a rotation is always now done with a capital R. It usually has a point here. We're going to call it O for the origin, and then we're going to have a degree measure. So for example, the first formula is 90 degrees. Now this angle means counterclockwise. All right, the only time it's going to go clockwise is if it is a negative angle, which we're not going to see in this video, and we'll talk about in class when we get there. So the formula for a rotation of 90 degrees counterclockwise is we're going to switch the order of the points, and we're going to negate the y value. So we're going to switch the order of x and y, and we're just going to negate whatever's here. So we write it as negative y comma x. And we're going to go through an example below on 90 degrees. The next formula is the same thing, rotation about the origin, but this time it's 180 degrees of any point x, y. We don't change the order of these at all. All we do is change the sign of both x and y. Now 180 degrees doesn't matter if it's clockwise or counterclockwise, because 180 degrees is always going to be halfway, whether you're going clockwise or counterclockwise. The last formula is going to be a rotation about the origin of 270 degrees counterclockwise. So the formula for this one is very similar to the first. We're going to switch the value of x and y, except this time we're going to negate the x value this time. So it's going to be y comma negative x. Now there is a way to do these three different rotations using your graph and not having to memorize the formula, but I find that it's easiest if you know these three formulas off the top of your head, and then we can kind of use the other method as, a helper if you need it. So right now we're going to get into three examples using these three different formulas. All right, our first example, or our first formula we're going to use, is a rotation of 90 degrees. Now there's a positive 90 degrees, which tells us that that's going to be counterclockwise. So that means if it's counterclockwise and it's a positive degree measure, we can use our formula that we learned above. So we're going to take our rotation of 90 degrees formula and we're going to use it. So what we have to do for that is we have to switch x and y and negate whatever the y value is. So we're going to take this 3 comma negative 2. We're going to switch the order and we're going to make it negative 2 comma 3. And we want to switch the value of negative 2, which is going to make it a positive 2. All right, we're going to call this point P prime, and I'm actually going to graph this one in green so you can see the difference. So point P would be 3, negative 2, should be right here. And then if we rotate it 90 degrees counterclockwise, it's going to go in this direction. So if it's going counterclockwise, that means point P prime is going to be somewhere here in the first quadrant. And if we plot our point 2 comma 3, we realize that it does wind up here in the first quadrant. So remember, any counterclockwise formula, any counterclockwise rotation, you can use the formula. All right, the only time we're going to go over, the formula we're going to use is the rotation of 180 degrees. Now 180 degrees doesn't matter if it's clockwise or counterclockwise, but all we have to know for the rotation of 180 is we're going to take both signs and switch them. So whatever's negative is going to be positive, and whatever's positive is going to be negative. So we're going to take this negative 3, negative 4, and we're going to turn it into 3, positive 4, and we're going to call that K prime. So I'm going to graph my K. Negative 3, negative 4 is here. And I'm going to graph my K prime in green again, which is going to be 3, comma 4. This would be K prime. So So make sure that you plot your pre-image and your image using the primes and the same letter. And our last and final formula here is going to be a rotation of 270 degrees. So since they didn't specify what direction it means, that means it's going to be counterclockwise. So if it's counterclockwise, then we're allowed to use the formula above because that's what it's for. So a rotation of 270, is going to be, we're going to switch X and Y, and we're going to negate whatever comes second. So we're going to take 1, 3, we're going to switch to orders 3, 1, and we are going to negate the second one, which is our 1. So make sure that we plot both. Let's call it A, and when we plot the second one, we're going to call it A prime. So this is how you use all three formulas. These are all for counterclockwise rotations. The only time you're going to use a different formula or we're going to talk about something different is if it's clockwise. We're going to discuss that more in class. So if they ask you for a rotation and they don't tell you what direction it goes in, that means that it must be counterclockwise, and you are allowed to use one of the three formulas over here that we started with. All three of these formulas are for counterclockwise rotations.